Hello everybody and welcome back. I hope you guys are all doing extremely well today. So far we have looked at the energy of reactions, and today we are going to move on and look at reaction rates and talk about some of the things that actually can affect the rate of reactions. So just to get started, as you know, some chemical reactions are fast and others are slow. However, fast and slow are inexact relative terms. So if we're looking at a chemical reaction occurring naturally on its own, we could say, oh, this one's really fast because it takes 0.2 seconds for the products to form, or this one's slower because it takes, 5 minutes for the products to form. So really it's a relative term saying fast or slow, because you can get very specific rates for how long it takes for the reaction to take place. So a lot of times chemists do need to be more specific. So we generally define the average rate of an action or process to be the change in a given quantity during a specific period of time. So basically, how much of the product is made over a specified period of time. The rate of a reaction can be described by the increase in the concentration of the products with time, or the decrease in the concentration of the reactants with time. So again, basically just from a more simplistic level, this is how long does it take for these products to actually form? What is the specific rate of reaction? What is the specific rate of the formation of these products? Okay, so when we're saying the increase in the concentration of products, so more products being made, and then the decrease in the concentration of the reactants, it means we're getting less of those reactants because those reactants are going into the equation, making the products that are coming out. So we calculate reaction rates by determining them experimentally. Okay, so we measure the concentrations of reactants or the products in an actual chemical reaction. So this is done experimentally. You can do it in the lab. And then you use math, everybody's favorite. You guys are not going to have to actually calculate reaction rates. You just need to be aware of reaction rates and then what are the factors that do affect them. So one of the things we need to go over is collision theory. And according to collision theory, atoms, ions, and molecules must collide with each other in order to react, which makes sense, right? Because if you're making a new product and forming new bonds, you actually have to get those molecules close to each other so they can actually bond and form. So there's a few things we need to know about this theory. Number one, the particles must collide in order to react. Okay, so they must collide, they must come in contact with one another to react and form your product. Number two, the particles must collide with the correct orientation. So what that means is basically they have to be at the right angle and they have to collide in exactly the right spot in order for the products to be made. And then number three, the particles must collide with enough energy to form an unstable activated complex, also called a transition state, which is an intermediate particle made up of the joined reactants. And we talked about that yesterday in our energy of reaction notes. So we already know that the activated complex, if we're looking at our energy diagrams, are at that peak, and the activation energy required is that difference in energy from the energy of our reactants to the activated complex. And then once we reach that energy, we can actually get our forward reaction going and form our products, okay? So they have to collide, they have to be in the right position, and they have to have enough energy to actually form the complex. So the minimum amount of energy that colliding particles must have in order to form an activated complex is the activation energy of the reaction. So that's just a review because we've already talked about activation energy. And then those particles that collide with less energy than the activation energy cannot form the activated complex. Okay, so if you don't have enough energy, your reaction will not take place. So in an exothermic reaction, remember heat is being released. The molecules collide with enough energy to overcome the activation energy barrier, form the activated complex, and then release energy and form products at a lower energy level. So remember, if we're looking at one of these energy diagrams, here we've got our products, the energy of our products lower than the energy of our reactants. That's going to be our indication that this is an exothermic reaction, okay? So this is just kind of the application of collision theory to an actual exothermic reaction. Okay, So now that we've talked about what reaction rates are and how we calculate them, let's take a look at some of the factors that can actually affect our reaction rates. So number one is just the reactants themselves. What is their reactive nature? So the reactive nature of the reactants affects the rate of a chemical reaction. Some reactions are naturally slow because the bonds involved are strong and unreactive, or the electrons are tightly held. So the stronger bonds you have, typically the slower the reaction will be. The greater the number of bonds being broken and made, like double or triple bonds, the slower the reaction. Okay, so on a molecular level, the way that these compounds are formed and the way that their bonds are oriented can affect how quickly a reaction will take place. Number two is concentration. So when we talk about concentration, we're talking about just how much is there, how much reactant do you actually have. So another important factor is the concentration of the reactants. Typically, reactions speed up when the concentrations of reacting particles are increased. So this increases the number of reactants because it increases the probability of collisions. Okay, so if we have, if you're starting with, let's say, just like 5 molecules and you're trying to form a compound and they're bouncing around in a chamber and you're trying to get them to collide with the other particle to make your products. Well, if you've got 100 molecules versus 5 molecules, you're going to be more likely to form those products if there's 100 molecules because they're going to be more likely to actually come into contact with the other molecules to form the activated complex. Okay? So think of it like, let's see, what's an analogy that we can use? Let's talk about baking. Okay, let's say that you want to make chocolate chip cookies and you've got like a cup of flour and sugar and you've got some chocolate chips and you have a set concentration of those that will make, let's say, 15 cookies. Okay, well, you decide that you want more than 15 cookies, so you have to increase the amount of ingredients that you have. So you have to get more flour and more sugar and more cookies. So the more concentration or the more overall ingredients that you have, the more cookies you can eventually get out in your products, right? So the same thing with the concentration of molecules. The rate of gaseous reactions can be increased by pumping more gas into the reaction container. So you just add more gas and you have more of a reaction. Surface area can also affect reaction rates. So increasing the surface area of reactants provides more opportunity for collisions, which makes sense, right? If you've got a larger surface area, it's more likely that something will come into contact with you. And then this overall increases the reaction rate. Temperature is also a factor that can affect reaction rates. Generally, increasing the temperature at which a reaction occurs increases the reaction rate. So the two are intertwined. So raising the temperature raises both the collision frequency and the collision energy. So here is a chart depicting your relative reaction rate versus your temperature, and we can see as we increase the temperature, the condition under which the reaction is happening, we see an overall upward trend of our reaction rate. Okay. And the reason why you need to know all of this is you just need to be aware of the concept that you can manipulate chemical reactions by changing conditions, right? So if you are running a reaction in the lab, you can manipulate temperatures in order to get your reaction to run faster, or if you want it to run slower, even to get it to run slower. So different conditions put these chemical reactions under different stressors, and it can change the rate of reaction, basically changing how quickly your products are formed. Number 5, adding a catalyst. So adding a catalyst will change your rate of chemical reaction. So this, remember from biology, a catalyst is a substance that increases the rate of a chemical reaction without itself being consumed in the reaction. So catalysts are not included in the chemical equation. One of the catalysts that you guys are probably most familiar with are enzymes. So those are the biological catalysts. And catalysts increase the rate of chemical reaction by lowering the activation energy. So it requires less energy to get your reaction going, so it can increase the amount of products that are being made in the same amount of time. Okay, so you're increasing your reaction rate because you're decreasing the amount of energy that it actually takes to get the reaction up and going. And here is a little depiction of this. So we've got our reaction progress, so the time of our reaction on our x-axis, and then our energy on our y. So again, we have our reactants on the left and our products on the right. And here is just a normal chemical reaction that's let to go on its own. So this is a natural reaction. So this is with no catalyst. And then we add a catalyst that lowers the activation energy. And here's the new curve, right? So basically, instead of having to take this much energy to get our reaction going, it only takes a fraction of the energy. So it takes less time to actually form our products, okay? And then another factor that can affect reaction rates are compressing gases. So if you compress something, you make it smaller. So when two gases react, compressing the gases or increasing the pressure, so if you increase the pressure in a gas chamber, you basically reduce the amount of area that the gas has to bounce around, and this generally increases the rate of reaction. Okay, so that was a super quick lesson today. We went over reaction rates, how to calculate them. Remember, we do that experimentally. A reaction rate is just the number of products that are formed over a specified area of time or specified amount of time. And then we talked about the things that can affect reaction rates. So if you have any questions, of course, you can always set up a tutoring session or reach out via email or Remind. Your independent practice today is just a quick 10-question quiz, practice quiz that you can take twice. So it's set up in Canvas for you guys to complete it twice. If you don't do so well the first time, you can take it again. And it covers concepts from today's lesson and yesterday's lesson. So if for some reason you skipped Monday's lesson, go ahead and go back into there and finish that first, because your quiz today covers reaction rates as well as some energy diagrams from yesterday. So that's it for your lesson for today. I hope you guys all are doing well, and let me know if you need anything.